So without further ado, we've got ASGI with John Napiorkowski.
I need to unmute.
You need to unmute. Go ahead.
Okay, I'm unmuted. There's no echoing? Okay. All right, everybody, cool. I know we're running late, so I'll keep it tight. Perl Asynchronous server gateway interface, a lengthy title. I'll probably change the name of this project at some point. That's sort of a working title. But what are we talking about here? So, like a lot of programmers, I do open source work. I do open source work often for two reasons. One, I'm getting paid to do it, which we all love when we can get it. And two, I work on things that I find fun, interesting, or I'm trying to learn something. In this case, I started this project because I was trying to learn something. I'm very interested in improving my understanding of asynchronous and event-driven programming. And I always wanted to learn how to build a web server properly. And I wanted to do something that I thought would be sort of useful for the community while I was learning, so I took on this project. So, what is, and like one reason why I'm going to change is ASGI, I guess it's sort of hard to say, I don't know. So what are we talking about? So for people who have been involved in web development in Perl for a number of years, when I say PSGI and PLAC, you probably know what I'm talking about. So PSGI is a protocol that creates an abstract interface between web applications and web servers. So the idea is if you have a web application, either you wrote it by hand from scratch, or you're using a framework like Catalyst or Dancer or Raisin or one of the other frameworks that use PSGI, that talk PSGI standard, that means you can hook up those web servers or your own custom system to any web server using this protocol. And it's a very, very simple protocol, and we call it PSGI. PLAC is the reference implementation that was written by the author who ported PSGI reference documents from Python. In Python, they called it WSGI. So when they brought it over to Perl, they called it PSGI for Perl Server Gateway Interface, right? And when it came out, people were really excited about it. It got a lot of interest and traction. A lot of web servers, a lot of web frameworks immediately moved over to it. Catalyst ported itself to run underneath it. For example, I was involved in that project. Dancer did. Other people, and it made it so also so that people could sort of build new web frameworks without having to worry about the underlying server guts. So, what is PSGI in a nutshell? Can you see this is too small?
No, I'm zooming it right now. You're good.
Okay, so basically, a PSGI application is an anonymous subroutine that accepts an environment and it returns an array ref that is expected to be formatted in a very specific manner. So it's an array ref with three items in it. The first item is going to be the code, or the HTTP code, so in this case 200, or it could be 404, or 43, or 500, or whatever. Any allowed status code is the first piece. The second array ref is going to be a list of the headers that are part of your HTTP response. Anybody that knows anything about HTTP, anybody that knows anything about HTTP, you know it's got a code. When they respond, there's headers, and then there's the last piece, which is the actual response, the body response. And in this case, the body response, again, is an array ref. Quite often, people just send the response as one big string, but it can be an array ref of strings concatenated. I'm going to caveat that there's, in addition to this array ref-based return, PSGI also allows you to return a callback that is used for streaming, but it's not used very much because it's not a very good streaming system, which I'm going to get to in a moment. So just in a nutshell, this is what PSGI is. It's very simple to understand, very easy to adopt, but it's got problems. I list some of them here, but the major issue with it is that it really only does HTTP 1.1. And it really only is good at old school, like 1990s style, like request response, right? So it's as it's written here, it's synchronous. You get a request, you expect a response, beginning and end. That's it. It doesn't, and I know that if you go to MetaCPAN and you look up PLAC, WebSockets and stuff, you're going to see attempts to graph WebSockets into it, attempts to graph server-side events into it. They're not very good, okay? They're not very robust, and they're not standard and so that you can't really, you can't really have it so that you could build like for example, a web service application that would run, say, on Catalyst and also on Dancer using the same underlying protocol. It's all done very differently. So people have tried to work around it, and it's not very, very effective. Again, you can't really do asynchronous, so it doesn't really do streaming very well. It doesn't do streaming incoming, can't do streaming outgoing. Okay, as I said, it's got in theory a streaming interface, but it's not very good, and I'm not going to go into details on it. And of course, ultimately, it only does HTTP 1.1. That's it. Now, its simplicity is part of its charm. It's why it was very easy for people to adopt it. As you can see, anybody looks at this code, very quickly picks it up. You can write very simple web applications with it. It was very easy, for example, to make Catalyst work with it. It was not a lot of work to get all these pieces, underlying pieces to go. But ultimately, it's limiting. And be quite honest, by the time we ported WSGI to Perl, it was already considered, PSGI was already considered like an ancient interface that they were thinking was not really going to be very forward-looking. It was going to have to be reinvented. A couple of the quick things I'll mention is, it doesn't have, it only does the HTTP. You don't have any life cycle. You don't have any ability to do meta inspection between your, to do like sort of a capabilities analysis of the server you're running on. It's just what you see here, that's all it is. The environment variable is just the environment variables that come in from the web server, and the response is just a very simple response. Is there a way, do people ask questions on this? I'm sorry, I know
They can if they want to, and you will hear them.
Okay.
But just go ahead and keep going.
Fantastic. Okay. Well, if for some reason I don't hear a question, please somebody interrupt me. And just feel free to ask. I mean, people are probably familiar with PSGI, so I don't want to go more detail about it. So one workaround, you might see, like, for example, people trying to make something like WebSockets work with it. And again, it's not part of the spec. It's sort of like extended to the spec, and it might work for some applications, but it's not very robust, and it's not something that like you can hook it up to any server. Yeah, it's not really PSGI at this point. Now, so given all those limitations, what are we going to do? We have a lot of applications out. We liked the idea of Plaque. We liked the idea of PSGI. It clearly was something that excited the community. What is next? So the easiest thing to do was to go look at the people who did WSGI did. The people who did WSGI, the Python group, they came up with a follow-up spec which they called ASGI. Okay, so Asynchronous Server Gateway Interface, right? That was the upgrade from WSGI. And the idea was they wanted to have something that was similar enough that it would be easy to port over, but that would remove all the limitations. Okay. Now I know I got some Python code down here, which may not be everybody's favorite language, but I just thought I would show it so that you can understand what's going on. In ASGI, it's very, very similar to PSGI. You have a subroutine that accepts stuff and has to respond to things. Now you might see it's got this fancy async in front of it. That's just because it's an asynchronous subroutine, which means is that it's event driven, and it allows you to not block on the call. So on the incoming, you're going to get, unlike with PSGI or WSGI, instead of getting just an environment, a dictionary or hash ref, which is what we have in Perl, you get 3 bits incoming: scope, and then 2 callbacks: receive callback and a send callback. The scope is just a hash ref that contains information about the it contains information about the server you're running on, and to a certain degree about the request. Okay, and as you can see, there's a condition here where we're checking the scope for something. Is that a question, or is that somebody's phone ringing? Okay. So you can see here, it's the first thing we're doing is we're checking for the type. And in this case, it's HTTP. Just so you understand, this could be used for not just responding to HTTP requests or WebSocket requests or server-side event requests. It allows you to define things like a life cycle for the application. So for example, you could have, when the server starts up, it calls for a life cycle request that runs, say, once at the beginning. So you can do maybe some application setup, maybe create like connections to the database or heat up your cache or whatever. And then it'll have like a life cycle at the very end when when you stop the web server, it'll do a life cycle end, which might be like you do some cleanup. And you could do all sorts of other things. In fact, you can build your own custom event-driven protocols. So like for example, some people might build like some telemetry information on top of it, or you could build an event-driven job queue on top of it. So the idea is that they have a generic system for creating eventable code that has a very clear interface. So that's the scope information is going to tell you what kind of request this is. Then, as you can see, like you're handling it differently if it's HTTP versus WebSocket. And at this point, then you take the receive. You can do things like poll. If there's any post body or any query parameters, and then of course you get the send callback, which you use to return a streaming response. Okay, so in a nutshell, it's very, very similar in appearance, but it's much more powerful. Okay, first of all, it's asynchronous, so you have to use asynchronous code. That's the first piece. The second piece is it allows you to escape being driven just for doing HTTP. So let's bring it over. What does it look like when we bring it over? Well, let's just skip this piece here. Then we're running this out on time. Let's actually look at the pro code. So I wanted to bring these concepts over to Perl, and the project that I'm going to show you. It is a work in progress. It is like something that I'm using. As I said, I want to learn asynchronous code better, and I want to learn how to build web servers. So I'm going to show you a working demo, but it's very, very thin. There is code on GitHub. If this is exciting to people, I would really great to hear from you, because I would prefer not to work on it by myself. All right. So first piece is that in order to get Perl does not have built-in primitives for handling asynchronous code. We have a couple different approaches doing asynchronous code on GitHub, on Meta CPAN. And I chose to work with IO Async group because one, it's got the pretty mature implementation, and there are more people working on it. It's got quite a few bits of code, and it's also there's not an unreasonable chance that some of the code that's part of that project could find its way into a future version of Perl. So it kind of like brings you into that general idea. All right, so again, main thing is with PSGI asynchronous, you can only do it for HTTP. It's really just single call. I wrote here limited async, but it's basically like once you try to do anything that's asynchronous, it's really no longer PSGI. You may as well have built your own server. Okay. PASGI, it's asynchronous from built in. It's multi-protocol, so it can the idea is it will natively handle WebSockets. It'll natively handle HTTP 1.1. I'm hoping to be able to support HTTP 2 and maybe even HTTP 3. I tend to have it to support server-side events as well. So what does it currently look like? So this is an example of some code that I'll show you running in a little bit. It's very similar, of course, to the Python code, but it's been ported over to use things that make sense for Perl. So again, you have a subroutine. I'm using future async await to mark the subroutine as an asynchronous subroutine. Future async await requires Perl 5.20. So that's potential. I'm sorry, 5.16. So it's not compatible to like Perl from the 90s, but if you're using a version of Perl written anytime in the last 15 years, it works. Okay. And again, like the Python version, the subroutine will receive. The subroutine will receive 3 arguments. The first one being scope, and then a receive and a send callback. So again, just looking at it here, when you're incoming, first thing you do is you check the scope. And in this case, if it's an HTTP scope, I know it's an HTTP request and I want to handle it. Otherwise, I currently, and this is something that I'm still sort of trying to decide. In my example here, I'm just saying my application doesn't support anything except HTTP. The ASGI specification doesn't actually specify a system for handling exceptions. That might be something that I may decide to clarify in the Perl spec in terms of what to do here into these. So like if your application doesn't support it, should you die or should you return something else? Right now, I'm just dying, but it's possible that as I update the spec, that might be something that we want to handle better other than simply die out. So if the application request is an HTTP type, the first piece you get is you're going to get any request information through the receive callback, and then you're going to build a response. Now here's where it's very, very different from PLAC or ASGI. And ASGI is just a simple array ref. In PASGI, you have this send callback, which you're going to evoke and send parameters based on the type of request that it is. Now, since it's a HTTP request, and this is part of the spec, which is written out, what you're supposed to send back. So in this case, I'm saying the first thing I'm doing is I'm saying I'm starting an HTTP response, and I'm giving status and headers. Then the next piece I'm doing is I'm streaming the body. And in this case, I'm just streaming the body information and I'm marking it as I'm saying it's done. More means more, zero means no, nothing more. So if you ran this application, you would just simply expect to see hello from PSGI when you hit it. But one thing that's cool here is that you can say more equals 1 and you can continue to stream. And I'll give you an example of that when I actually run the real example. When we do the code example. And here's what a WebSocket example could look like. So again, on the incoming, you're going to check for the scope. You're going to check the scope type. And if it's a WebSocket response, well, then you handle the WebSocket response. So that'll be built in natively to the protocol, right? And so again, the protocol will support HTTP 1.1, WebSocket, server-side events. By default, that'll be part of the definition of the protocol. You can build your own protocols on top of that if you want, based on the way this works, and people do. So in this case here, I have a WebSocket response. I'm getting the data, and I'm just simply streaming information back. And then this becomes, again, it's part of the protocol, which means is that if a web server that's implementing the PHI protocol supports WebSockets as part of its handshake, then that means any web framework that implements PSGI would get WebSockets for free as part of how it works, right? So it's just part of the specification. I think I covered bits of this, but in general, the core parts of the protocol will be HTTP 1.1 at least. I'm hoping to support 2 and maybe 3. HTTP 2 is a little tough because the libraries for Perl for HTTP 2 are not super complete. WebSockets, on the other hand, we do have a good support for, and same thing with server-side events. Another part of the core protocol, which is really, really useful, is the lifespan, which is, again, like when the application starts up. This is something that like would have been really handy to have with PLAC. Like when the application starts, I want to do something. When the application dies, I want to do something. Right now, the only way to do that, you can handle it custom in your web framework if you want, but then that's not portable across web frameworks, right? So this gives you like a portable mechanism for handling things like server starting, server ending, and other lifespan events like errors, right? Again, you'll be able to build your own custom protocols on top of it. I'm not going to talk too much, but like ASGI and PSGI, you can create middleware, and so middleware is composable bits of the application that can be grafted in. So, if, for example, you might have like logging middleware, or you might have authorization or authentication middleware that can be that you can use in your application, and that way you don't have to rewrite it. So like, for example, if we had ASGI that people could build against, and there was like a core set of middleware for like doing things like logging and authorization and authentication, then somebody building a web framework on top of that would not need to build their own custom authorization and authentication stuff. They could just build it on top of the existing middleware, right? I know we have some of this in ASGI and in PSGI as well, but again, since it's kind of a thin, since you can't really do like inspection and so forth, it doesn't work super well. Ultimately, we're also I'm planning to have a bridge to make it so that if you have a application that was written to the PSGI specification, there'll be probably a piece of middleware that will convert PSGI to ASGI so that you can use your PSGI enabled servers to run your legacy applications. So that's sort of like the goals of the project. Currently, I have on GitHub, I've ported over the specifications, handwritten specification. Love to get people's feedback on it. I have a very, very basic proof of concept server, which I'll show you in a moment. I've had, I'm not going to show you today because I broke it, but I've had like WebSockets and stuff working on it at one point. Ended up breaking a lot of stuff because as I've gone back and learned about how to build a good, robust web server, which is actually not easy, as I've learned, I ended up breaking pieces. So I'm only going to show you a small piece, but I'll give you a taste of it. But I think the idea here is if we can get it to work, then it gives people a path forward who want to build like modern asynchronous applications in Perl, who like right now, if you want to do this, you pretty much have to use Mojalicious, right? Because that's the only like system that actually really works effectively. I have nothing against Mojalicious. I love the people working on it, but it's also, no, I do.
Okay.
No, I like Sri. He's a great guy. And what they've done is
I
very,
like one of the guys working on it.
Okay.
There's one good guy on that team.
no. All right. So just to be really clear, I have nothing against the project, but it makes a lot of like decisions that are different than the way I would like to build frameworks, right? So like, I think it would be great if people had options. And my hope is that maybe Mojalicious people might take a look at this and consider either adopting it as part of their stuff or at least be able to work with it. Let's keep it tight because I don't want to go too much over. There's a bunch of stuff that needs to be done. I mean, you'll see that. I mean, the example I give you is thin, it works, but a ton of things need to happen in order to make a good, robust web server and to build out enough of an ecosystem around this to make this thing viable. So let me switch over just so you can show you this is not vaporware that I just wrote slides for using ChatGPT. So let me stop that.
You wrote vaporware code as well using ChatGPT.
No, I only write code that works.
Okay.
I'm not going to give a presentation if I'm not going to show a demo. Okay, so let me share the whole screen. I think that's probably easiest. All right, so let me blow it up so you can see it a little better.
Yeah, you have to like maximize the window because it's.
All right, oops, I hit the wrong. It's the green. Okay, so this to show you the code. Let me just show you the code that we're going to run very quickly. All right, so at the very, since again it's event driven, I have to create a loop, an asynchronous loop that this is going to run under at the very top. All right, and then I have the guts of the application here, and it's just as you've seen it. It's just a subroutine that's marked as asynchronous. Now that you could have done this as an anonymous subroutine if you wanted. I made it as a method that I'm referencing, which is the same thing as an anonymous subroutine because it's a little bit easier for me to write. But again, just like with PSGI, you're just referencing it as a reference to a subroutine. So at the very top here, again, this is something I'm still trying to figure out. Since this application only handles HTTP, what do you do if the request is something else? Should it throw an exception or should it just like ignore it? I'm not really sure. That's part of the spec that I would love to work out. with other people. Right now, I just chat with AI about it. It would be great if I could talk to a real human. All right, so then here, the first piece I'm getting is I'm looking at the receive callback. So the receive callback lets you get things like post bodies. So I'm checking to see, is there a post body? I do it await that when you call the receive, it returns a hash ref that will have keys in it, like what the body is and so forth. That's part of the spec. When you go, if you go and you read the spec I wrote, you'll see that it defines what the receive is expected to do, right? All right, so and then getting down to the fun part. So we have a couple of sends, several sends, right? The first send is the setup, where we're saying that it's a start of an HTTP response. We're setting that it's a 200 response, a good response, and we're setting some headers, right? So very similar to PSGI, except instead of setting it all as one piece, I'm setting it as separate bits. Now I'm sending 3 separate body bits. Okay, the first one is I'm just doing an echo of whatever somebody might have posted, and I'm saying there's more to come. That's what the more means, right? Now, why would you want to do this? Well, you might, for example, be streaming a ton of data from, say, a database, and you don't want to have to write code that says load everything from the database into memory, build up a huge comment separator file, and send it all at once, because that's memory inefficient, and also it's a slower experience for your user, because they have to wait for the entire response to be built in memory before you can send it. Using an approach like this, I could create a, say, for example, a select statement on the database, and then and then iterate over it, calling each row, building a response, and then sending it as I went along. So that ends up being much more memory efficient for you as the writer of the application, because you don't have to load everything at once. And for the user, they start getting data right away. Okay, so that's, for example, one reason why you might do something like that. Now, just to show you, and when we will go look at the, I'll run this code for a second. I just wanted to show you how this would work if you were doing streaming. I'm going to send 2 more pieces where I set I just send the timestamp. And between these last 2 pieces, I'm just calling, I'm telling the loop to wait for 5 seconds. Okay, that is just simply to simulate perhaps some long running process that might run. Now, because it's running inside of a loop, and it's an event driven, unlike, say, for example, a classic like forking application, it doesn't block. It might be waiting for 5 seconds, but it could go on to handle requests from other people. Okay, so like it doesn't block the entire fork, is what I'm trying to say.
So one fork could handle multiple requests.
That's correct. Actually, and that's like, for example, the way Node.js for the JavaScript people work, right? They have one thread, and you have to be very careful to always write asynchronous code. Now, for Perl, we're probably going to need to do a hybrid where the server, and this is the way I'm writing the server is going to have to create a certain number of forks, but also be event driven, so that way, if you're happy to be running stuff that is blocking, for example, you might be using an ORM, like DVS class that does not currently support asynchronous code, that's going to block, right? And so you don't want, you're going to need more than one fork in order to be able to handle blocking stuff.
Okay,
There's
some things are limited to one process per fork.
Well, yes, it'll block on the fork. It'll block.
Okay.
So there are things you can do though, and one thing that I'm trying to get to work is, IOA Sync has like the ability to be able to fork off jobs into a separate process. So like that could be, for example, a mechanism if you're running some code that is not asynchronous by design, you can run it in a separate fork that's managed by the event queue, so that way it kind of goes on its own. There's a lot that, and again, like I'm far from an expert in how any of this works. So, anybody out there will feel free to correct me, but I'm pretty sure that we can make it work the way we want it to work. But in this case, I'm trying to show you what it would look like when I go to how a streaming response would look like, where if there was potentially like lengthy things that needed to happen on the way. Again, with a classic application, and you would run all the lengthy painful like SQL and all the lengthy, complicated template generation, and then you would send it all at once. And so the user is going to wait for that entire amount of time, and for the entire amount of time, the entire process. Like if you only have 10 forks, that whole fork is held for that time period. Whereas in this case, if it's done properly, it's not being blocked. All right, so this is the application, very simple application. So it's going to, the first piece is an echo. The second piece just sends the time. Then we wait 5 seconds and sends the time. I'm not like, you know, and then I start the application, I run it. So just to be really clear, you know, again, I'm still learning. It might be better ways to build the interfaces for this. I haven't decided yet. Let's go ahead now and run the application. People can see it. We'll try to wrap it up. I know we're basically out of time here. So
Yeah, we have time for a quick demo, absolutely.
okay, just do real quick. So
Is that it?
no, let me.
Oh, okay. I was
No.
gonna say, that was really quick. Whoa.
Here is the. So I'm running the application. Hopefully it won't break the window. Yep, it ran, and it's
ASGI-basic.pl. Oh, and there's Randall.
so what happens.
Oh no, not Randall.
Okay,
We're still in the middle of our talk, Randall.
we're almost done. Like got like 2 minutes just to show you. So I'm gonna curl. I'm just using curl. Okay, so what do we expect that's gonna happen? Let me run it so you can see what happens. So the first thing that happens is it echoes back what you sent. That was part of the D, and then immediately sends the timestamp that was part of that first bit of the application. As you can see it again, then it blocked for 5 seconds.
Zoom that at all?
Yeah, I can zoom it.
It's just so
Is that big?
small. Oh yeah, that's
Is that better?
okay. That's even better. Thank you.
So again, it's streaming properly.
It's
Okay.
echoing back what you sent it,
Yes.
and how do we know that it's streaming properly?
Well, you can
What
see it's.
behavior tells us that?
Well, you can see that because the way the response it sends the first 2 bits, it then performs its blocking long complicated stuff, and then it sends the last bit.
Oh, the 5 second passes.
Right.
That's the idea.
So I know that it's really just sort of contrived. I just wanted to have something that worked for the purposes of showing it. But
no, I get it, but it's the 5 second delay between the last 2 timestamps that tells us that it successfully simulated
streaming. Correct.
Okay.
So in other words, each piece is set. And again, just to go back to the application, to the people can, again, now you've seen it run. So you see that coming in. Again, the first piece is it checks the received callback. It gets an event from the received callback. Okay. Now this is now again, since this is HTTP1, you're only getting, we're not streaming anything in. Okay. So it's just getting one event. But if this was a streaming input as well, you could expect to have the call receive more than once, right? In order to get each individual piece. Now that's not part of this demo, but that's how it could work. Then again, I'm starting the response. I'm setting the headers, and then I'm sending 3 separate blocks of response with a long running something in between, right?
Which could be several long running somethings of any arbitrary nature.
Correct.
Okay.
Okay. And the idea again is that, you know, again, you could be looping over, say, reading from a very big file, or you could be looping over calling records from a database, and then like you prepare the response, send the line, prepare the next line, send it, prepare the next line, send it. As opposed to under current set scenarios where you have to read everything all at once into memory and take up a lot of memory and a lot of time, build your entire response and send it all, and then send it all.
So
right.
I do have a question. Tell me when you're done with your presentation.
And that's basically it.
I'll try and make one quick question.
Okay.
What is the difference or similarity between the ASGI or asynchronous approach that we're looking at here and what was at one point called Web 2.0 or AJAX, asynchronous JavaScript and AJAX? Because I actually did use, there was one very obscure and difficult to use, but actually functioning Ajax library for Perl, and I did use it successfully in Catalyst, in Shiny, a long time ago, so I know it's real. But it basically kind of allowed you to have things running without having to keep making repeated responses, I guess?
So,
Is it a similar idea?
well, it's not really.
Okay.
Okay, this is about how the server works. When people were calling, what people called in the 90s Ajax was a way of being able to update the application through sending requests directly from JavaScript to a server and then getting a response and updating the page, perhaps bits of the page, rather than having to do a whole refresh. I mean, up until that point, every application that was written was like, you know, you type something, a form, you hit go, it refreshes the entire page, right? So the thought was we wanted to get away from having to refresh the entire page, and you wanted to be able to build much more complicated applications where you could sort of scope behavior to specific parts of the page. And so that's, you know, like Ajax is what we might call single page application style nowadays.
Okay.
I'm not really sure why they called it asynchronous, because it's not really, I mean, I guess it's asynchronous because JavaScript running inside the browser is sort of asynchronous because it's event driven. But it's not
Microsoft implemented XML-based requests.
well, that was what it was, right? Microsoft, when in a version of Internet Explorer, they did an extension. We're getting way off topic, but they did an extension to the web browser specification for JavaScript to allow you to make HTTP requests from JavaScript. Right before that, if you couldn't do that, you could not make HTTP requests programmatically from JavaScript. I don't want to say you couldn't. You could do wacky hacks using like invisible like images to try to load data and stuff.
Yeah.
But it was really complicated. Like I did it like in '95, right? It was really complicated and it was ugly. They created an extension, and eventually that extension became sort of part of the standard, and other browsers adopted it, and now they've even gone further and improved it in the more recent specifications. When I say recent, I mean like the last 10 years of like web browsers have a even better a form of being able to do that, but there's no real relation.
Okay, well, that is interesting, although it is far afield. So let's stop there because we've gone 10 minutes over time as of right now. Okay, so thank you, John.
If anybody's interested in this project and wants to like work on it with me, ping me. I'm JNap on IRC or whatever.
Wonderful.
There's any ways to find me. I mean, my last name is Napiorkowski. I'm easy to find. Just Google
There's
it.
not around.
I did. Yep.
Okay.
And